Hello everyone, this is a video lecture for Calculus 1, section 4.3, derivatives and their graphs. So, this is a longer section, and I'm going to try to just cut to the chase on a lot of this stuff, but ultimately it's going to be a lot of content. Thankfully, it's the same thing again and again, so whatever we're going to do it about 50 times, that'd be great. So, let's just go through some of the principles of what we're going to be seeing. F of x is the height of the graph. It's the y value. It's how high. F prime of x is, when it's equal to 0, tells me the mins and the maxes. We've been learning that already. F double prime is equal to 0. This tells me inflection points. Now, we have not talked about inflection points. I love this cubic. I draw it for like everything, apparently, because it has everything you need. We have a maximum, we have a minimum, and we have an inflection point about right there. I'm going to use just a dot. Let's call that my inflection point. IP, inflection point. Okay, so what is an inflection point? Well, you'd almost have to zoom in to see it a little bit better, but zooming out is, I guess, fine. Notice right here, see how it's like cup down, and here this is cup up? Basically, it's about concavity. This is concave down, and this is concave up. And somewhere there's a transition, and that transition is the inflection point. That's where it transitions between concave up and concave down. Okay, so now that you see that, let's give you a couple more things. So this is a cool list. I'm going to add just a tiny bit more. If your f double prime is greater than 0, that means that it's concave up. And if your f double prime is less than 0, it means you're concave down. Okay, now hold on. This is where things get a little mixed up sometimes with folks, okay? I think this makes sense because positive is concave up and all that kind of stuff. But notice that when it's concave up, what are you yielding from a critical point? This will tell you if it's a minimum, okay? And this will tell you if it's a maximum. So it's weird because maximums occur when your second derivative is negative. And you would think maximums would be more like positive, big things. So it does kind of look a little weird here, but this is the more standard, for sure it always works. And I don't know if they particularly reference this. I was taught this so much. I was taught that second derivative does the mins and maxes and all this kind of stuff all the time. Curve sketching is what we always did. Curve sketching. And this will definitely be similar to curve sketching, if not right on. And so anyways, it's something that I was taught. I kind of tell you a little bit, I guess, too. But there you go. Okay, 43008. Let's talk about it. We got f of x is equal to x cubed, my friend, minus 9x squared minus 21x plus 2, not my friend. So we got lots of stuff going up here, and they want all kinds of things. And these will not be ever changing. So I'm going to give you the A through D right now, and I won't do it ever again. I'll just tell you that we're finding it. I'll, of course, remind you of this stuff. But they're saying find the increasing. This is all permitted that I actually know how to spell. And decreasing intervals. Okay. Whatever that means. It says find the mins and the maxes. Okay. apparently they want y values. I'm just writing down what's in my notes here. C, they say find the inflection points. Here you only have the 1, of course, but inflection points. And this they want in the form of x comma y. Kind of annoying how they want two things. Here they want this one, and it's not a lot of consistency, which is kind of meh. And then finally, find the intervals of concave up and concave down. Okay. I think that we need formulas because that's just what we're going to do here. But before anything else, I really need to talk about the increasing and decreasing thing. This is actually something that we used to do in algebra. I remember it distinctly. It's chapter 2, section 2.1, question number 15. That's just a joke. I have no clue. I can't remember. But it's somewhere around there. Actually, it's 2.2. It's chapter 2.2. Blah, blah, blah. How are we doing here in calculus land? Well, let's do my cool cubic again. And if you notice, we're increasing, decreasing, increasing. Its transitions are at maxes and mins at critical values. Okay? Critical values. So if we find the critical values, then we can pretty much understand if it's increasing, decreasing, kind of from that. And we can do the whole concavity thing to know for sure, but I feel that's too much. So critical values is what we're really looking for. So let me give you kind of like a formula for this, and then we'll never see it again. So increasing, decreasing intervals, I'm going to use my f prime of x is equal to 0. And I'm not saying it is just equal to 0 and call it a day. We have to use it to be able to get the intervals. Find the mins and maxes. Oh my gosh. It's probably when these are equal to 0 and you solve for x, and then you plug it back in and you solve for y. Okay, inflection points. This is when your second derivative is equal to 0. Solve for x, plug it back in, and solve for y. Find the intervals of concave up and concave down. Well, this time we're going to use my second derivative equals 0, and then we're going to find the intervals around that. So look around you here. What are we really going to do here? Well, we're going to take our derivative set equal to 0, take our second derivative set equal to 0. If you can see my eyebrows are raised. Ooh, really? Is that what we're going to do? 3x squared minus 18x minus 21. Set it equal to 0. So I think they all have a 3 in common. And so I can pull out a 3 from these guys. That's a square. And so I can factor this one. 7 and 1, I believe. So negative 7, positive 1. X equals 7. X equals negative 1. And these are my critical values. Okay, keep cruising, keep cruising. No time to stand around. Let's keep going. We got now second derivative, 6x minus 18 is equal to 0. Move the 18 over, divide, you get x equals 3. This is an inflection point. Okay, so I'll do inflection and I'll do critical. Okay, there you go. All right, well, I guess that's everything we ever needed. Honestly, we do need to go further, but let's kind of zoom out here for a second. Look at what we got. This is a positive x cubed. And we have a lot of cool points here. And so my positive x cubed is definitely doing this action. There's no doubt in my mind this is what the graph looks like. Now, negative 1 and 7 are critical values. These are mins and maxes. This right here must be a maximum. Just by looking at the graph, this is a maximum right here. right here. This must then be a minimum. Just looking at the graph. So this is -1. There's +7. There's your minimum. This is not hard. Not hard. And so 3, 1, 2, 3. There you go. There's your inflection point at 3. I mean, what else am I supposed to do? This is actually your answer for the graph. They want you to do a graph, so you click multiple choice and figure it out. But there are a ton of questions for this kind of question, so we have got to go and answer everything they ever wanted. Part A, where is it increasing? Well, looking at the graph, I'm okay. I know that I'm acting a little silly here. I'm just going to pause for a second. I am dead serious. You should use the graph for these answers. That is the point here, okay? We're just saying this is what the graph looks like, and we go and do it. Now, if you can't make this graph from all this, then, I mean, I'm not being weird, but you really got to go back and do some algebra, because this is not calculator graph requirements here. This is basic stuff. This is an x cubed, and everyone's expecting this guy for this kind of problem. We found all the numbers, and we just kind of threw them up, and there we go. I'm not being a professional here. I'm just doing a normal math, okay? I'm serious. And so sometimes I get a little careless, and I know I kind of go a little bit too, far maybe, and I'm sorry. I don't want to go that way. But this is actually a serious topic, okay? You got to be able to do this without a graphing calculator. You got to. There's no way around it. I don't make the rules either, so I'm just telling you how it is. But the graph is definitely going to help you be able to find all of the answers you need. So back to increasing. We're increasing here. We're increasing here. And so using the graph and obviously seeing a lot of my answers, this is no problem at all to find your answers. Now, here's the big question. Union or comma? It's actually comma. Yep, it's actually a comma. I don't know if the union works or doesn't work, but for sure, you need to go and do a comma here, and that's great. All right. So, where's it decreasing? Well, everywhere else. And these are always x values. These are always x values. Never go how high. That's not what we're looking for here. Okay, cool. So we did that. Increasing, decreasing. Now, we need to find what the minimum and the maximum values are. They're talking, of course, relative mins and maxes. They're wanting the y values. How high here? How low right here? I do not know. But could I plug in f of 7 to figure it out? See, minimum at 7. I plug it in. And so that would be 7 cubed minus 9 times 7 squared minus 21 times 7 plus the 2. Blah, blah, calculator. Negative 243. Yay! F of -1. Plug it all in the same, and you get a positive 13. Yay! All right, whatever. So you plug it in, use a calculator, of course. So for part C, it says, what's your inflection point? Well, I don't know. I'm looking around, and oh my goodness, it's 3. And so the way they have this is that you're supposed to have an x comma y point, so it's 3 comma something. Well, the best way to find the other one is to plug in 3. Plug in 3, da-da-da-da-da, plug it in 3, da-da-da-da-da. I get negative 115, and that's what you put in right here. So they want that format, okay? And part D, finally, they say, okay, where are you concave up? Where are you concave down? And intervals are always, again, x values. Concave down. So that's going to be from -infinity to 3. Wrong place. Concave up. 3 to infinity. And there's all the answers you ever needed for this problem. And of course the graph. So that was one problem. One. See how many are on this section? How many am I doing? I got how many left? 1, 2, counting here, 3, 4. Wow, that took 2 pages. 4. So like the whole section is just 5 questions that I'm doing. Yeah. But you can see how long it's going to take. So my point is, just be careful, go slow, understand the concepts. That's why I'm doing it here with you, okay? I'm not trying to make it weird here. I'm just trying to get through it with you, okay? And some of the questions are just downright not fun. And this is one of them. I could tell that it's a not fun question because I actually have a majority of the page crossed through because apparently I was doing something wrong. I don't know. So, before you go any further, look, this is the derivative. They are saying that the derivative is equal to all this stuff. And they're saying, when is f increasing? Okay. Maybe you were thinking that they were helping us. Maybe you were saying, the derivative's already done. I don't have to do anything else. Isn't that so nice to think like that? But indeed, they don't just do that. We got to do more. So where is it increasing? This is when we have a graph, which I don't know, this is some squirrely graph here. When my squirrely graph is supposed to be going up, 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 all the little ups that you can ever think of. It might only be one little place. It might be a whole ton of places. I don't know. But they're all determined by when your derivative is equal to 0. Your mins and maxes are telling you when this is happening. So, derivative, it's already done for you. It's already done for you, equals 0. Okay? That's it. You're done. Solve for x. What do you get? Well, I got it. So, x equals -2. And then I got right here, x is equal to 3. And then I got right here, x is equal to +5. Yay! To be most assured of where these answers are about what I'm looking for, I will actually draw everything on a number line and then test my intervals. Now, can you see the answer right here, looking at it from what we have? The answer is yes. I am not going to do that with you because it's not always a great way. It takes a lot of advanced thinking when you could just do something like this and always get it right without getting anything wrong. I need to test each one of these intervals. So I need your help. Give me a number that's less than -2. -3? Wow, that was a good answer. Okay, what's a number that's easy number that's between -2 and 3? It's 0. Very good. What's between 3 and 5? It's a 4. And what is a number? Oh, here we go. What's a number that's more than 5? It's 6. Yes, we're going to test these numbers, and we're going to see if these end up being, which way are they going? Now, here's the thing. Yes, this increasing stuff, mins and maxes and whatnot, well, increasing, to be straight with you, is when my slope is greater than 0, right? And then when I'm going up. So I want to know, when is my derivative greater than 0? Well, we found them when they're equal to 0. Now I'm going to say when they're greater than 0. I want them to be positive answers. And if I get a positive, we're good to go. So I'm going to plug these into the derivative. Here we go. I mean, this is silliness times 5. Because you are using a calculator, right? I mean, come on, what is that number? Come on, tell it to me. I don't know. Calculator, calculator, calculator. Have an answer for what I got from the calculator. It's negative. That's all that matters. And so this didn't work. When I plug in the 0, I go through all the procedures, blah, blah, blah. And it turns out to be another negative number. That will not work. 4, blah, blah, blah. Calculator, calculator. And guess what I got? I got a positive. Woohoo! I like that. Let's try the 6. Blah, blah, blah. 6. Plug it into 6. Blah, blah, blah. And I get a positive. Woo! I like it. So where is it increasing? It's increasing right here. That's my answer. I'm going from 3 to infinity. That's your answer. You're done. There's nothing else to do here. The end of the problem. On to the next problem. 4, 3, 0, 1, 4. So we got f of x is equal to e to the 6x plus e to the negative x. Who comes up with these formulas? I do not know. Find all the stuff. That's literally what I have written in my notes. Find all the stuff. All right, well, you know, that's what we have to do. So first derivative. This is a u substitution, but I'm going to go quicker because is it u substitution? Is that what you call it? No, chain rule. I'm sorry. See, I was thinking of integration. We're doing all that in calculus too. So, hey, look forward to that. So, anyways, chain rule says that there's going to be a 6 coming down into the front. I have to remember that y'all are Cal1, and I don't want to go too fast with y'all sometimes. Oh, there's a complicated inside. So there we go. Okay, and the same thing with this guy. You leave the inside alone. Oh, no. Chain rule. There you go. Okay. Sorry. Okay. And so what we got for my derivative is 6. E to the 6x minus e to the negative x. And I'm going to set this equal to 0. In order to figure out how to solve all this, I'm definitely going to move something over to the other side. And you would think, oh, the e's cancel. And they don't. Not at all. In fact, I don't think this is a good way to go about this problem. I mean, I had to do it, but maybe there's something I'm missing. Like, what if I were to write this as this guy? Couldn't I multiply him to the other side? So I've got 6e to the 6x, and now times e to the x is equal to 1. Divide this by 6, multiplying bases, you add their powers. So that's a 1x and a 6x. Guess what? That's a 7x. Now I need to solve for x. What do? You ln both sides. Very good. You remember that, right? That's from algebra and pre-cal. Divide by 7. And there is your answer. ln of 1/6. All divided by 7. And this is a critical point. Yes! Isn't that so nice of them? It's not just something easy. No, we don't want easy. We want ln of 1/6 over 7. Second derivative. Second derivative. That is supposed to be an f double prime. So, notice right here the same style is going to happen. We're going to get a 36 in the front. 36 e to the 6x, just cutting to the chase here. And we got two negatives. We're going to make a positive again. Oh my goodness. Set it equal to 0. You know, I actually don't have much work on this guy because this is actually interesting. What I did is I moved this over just like last time. And I got a negative e to the negative x. And I stopped. I'm saying that an e is going to end up being a negative. Can't happen. I got can't happen. And so what this means is that there's no inflection points. I don't know how we're going to answer that thing, but hey, you know what? It's going to happen. And so, okay, we got no inflection points. I got this one critical point, and we got this crazy formula thing. I don't even know what's going on here. What's going on, I don't know. Well, here we go. I got to try something, I guess. So what if I did f at this ln craziness? Okay, hold on. Is there an easier way to write this guy? Yes, there is. This is what I'm going to do, just for brevity's sake. This right here on the inside is 6 to the negative 1, and that negative can come to the front. So I got negative 1/7 ln of 6. I did not do this in my notes, but it's just so many times I had to write a stupid fraction that I just said, you know what? This is going to be better for us. So negative 1/7 ln of 6. And I want to plug that into the original right here. So I got e to the 6 times negative 1/7 ln of 6. And then plus, because that's what we had, e to the negative 1/7 ln of 6. All right, super excited. And if you do this, power here actually can come up back into the ln, okay, just for a minute. The e and the ln cancel, leaving behind, and this is where it gets so fun, 6 to the negative 6/7. And this guy here, 2 negatives make a positive, put it up here, 6 to the 1/7. This is everybody's favorite problem. Now, this right here is a y value. This is a y value for my critical point, okay? I don't know what that means, but I'm going to keep on going. I'm going to plug this into my first derivative. Again, I don't really know what's going on when I do this here. Actually, hold on. I know exactly what's going to go on. That's a 0. So what I need to do is find out if it's increasing or decreasing. Is it a min or a max or anything like that? How do I know this stuff? Well, how about this? What if I plug it into my second derivative? And you're wondering just like, why does he just keep on plugging this stuff in? Well, because we got to do something. And I'll tell you more about it here in a second, okay? So 36, 6, negative 1/7 ln of 6, plus e now to the negative of a negative 1/7 ln of 6. Okay. Wow. Yeah, that's wonderful. So awesome. So when I do this whole thing in the calculator and stuff, I get a positive answer, and that's good enough for what we're doing right now. Now, let's pause right now for just a second. So what's going on? I plugged it into all these things, and I got all this stuff. Let's start right here with this concept. I'm saying that my second derivative, I plug it all in, I get a positive. Whenever I got my second derivative is greater than 0, that's concave up. But it also means that we're talking about a minimum. And so what's going on is that this value here is a minimum. Okay. This right here is the actual minimum value. This is the minimum value. Like if they say, what's the minimum value of the whatever? There it is. You don't simplify, it's done. You don't have to do anything else. And I don't know what the graph looks like, but I could sure put it all together. One last thing. If this is a minimum, then what our graph kind of looks like is a bowl. And so what we're doing here is that we're decreasing, and then we're increasing, right? And there's my minimum. Cool. And so my intervals of increasing and decreasing are centered around this kooky little point. Now, they want all the stuff. So here we go. Increasing. Where am I increasing? I'm increasing from that point to infinity. I'm decreasing from negative infinity to that point. The minimum value, the y value that they want, is going to be that 6 negative 6/7 plus 6 to the 1/7, whatever. The maximum value. Well, I'm going to ask, look around here. We got this one guy, one value, one time it happened. Did I ever have a maximum? The answer is no. And so you would put D and E for your answer for this guy. D and E. There's no maximum. There you go. Okay, now they're going to ask for the inflection point. Okay. Was there an inflection point? No. D and E. And then they're wanting concave up and concave down. Well, it's always concave up, as we just learned a second ago, always. So I'm going to go negative infinity to positive infinity. And for concave down, we're going to go D and E. All right. 43039. This class will eventually be over, and then you get to take Cal2. Find the graph. Here we go. Find the graph. Find graph. So I've got f prime of 6 is equal to 0. I've got f prime of x is less than 0. Whoa, whoa, whoa. When x is less than 6. All right, you lost me. I got f prime of x is greater than 0. Whoa, whoa, whoa. When x is greater than 6. I'm just copying it verbatim, okay? F double prime of 3 is equal to 0. F double prime of 8 is equal to 0. I mean, really. F double prime of x is less than 0 when x is less than 3 or x is more than 8. Oh, my goodness. And f double prime of x is more than 0 for the interval 3 to 8. We're not done. The limit as x goes to infinity of f of x is equal to 3. And the limit as x goes to negative infinity is equal to 3. Oh my goodness. No, I'm serious. Just hold on for a second. Let's talk for serious here, okay? That's a lot. That's a lot, okay? And this is one problem, and I can't stand writing all that out. But we did it anyways, and it's for your good. Maybe not for mine. We have a critical point here. This is going to be a min or a max. I don't really know. But it says that my derivative is less than 0, so this is like basically going down. This is decreasing when x is less than 6. And so I'm decreasing, and then at 6, and then all of a sudden it says right here I'm increasing again. That's increasing. So guess what this guy is? That's a minimum. That's a minimum. Okay, so we got a minimum here at x equals 6. And then they say, oh, but we got 2 inflection points. Inflection points. 2 of them. Nice. And then they go on their little spiel here. Now notice that I'm saying that my second derivative is less than 0 for the outsides. It's greater than 0 on the insides. This is concave up. So this must be concave down. And so concave down, and then it's concave up, and it's concave down. Okay. And these are at 3 and 8. You know what? My minimum is at 6. That makes sense. And it says that this limit as it goes to infinity or negative infinity is 3. So here's the thing. I think what I'm doing wrong is this kind of idea here. It's following this curve here. Oh, come on, give me a blue color. Okay, it's following this curve here. I totally like that. But eventually it's kind of leveling off. It looks like, in my mind at least. And this y value here is at 3. So this is a y equals 3 kind of horizontal asymptote or something kind of like that. I'm not really sure. All right, so slap a big thing on it and call it a day. And I'm not kidding you. This is your graph. Let me draw it more nicely here. At 6, you have a dip, and then it comes back up. And this is at 3. And there you go. Pick this one. It's multiple choice. Here, actually, I have something written here. Wow. This is multiple choice. Pick something easy. Process of elimination. Okay. 43075. I have a graph, and this is actually something pretty interesting because it does this. Goes on forever, I think. And then 18 is really where we're interested, is 18. And then there's an inflection point at 8, not to scale necessarily. This is at 350, and it looks like at 18, it is at 700. Okay, or somewhere around there. And I've got to answer some questions. It says, where's the point where the rate is highest? Where's my slope of the tangent line being the highest slope? It's right there. Yup, you got it. It's at 8, 350. Ding, 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 ding. Okay. Part B, it says, hey, where's this thing concave up? Where's this thing concave down? And we've got to do our intervals here. 0 to 18 is where it's cutting off. Okay, so let's just not think about anything past that. Concave up, and then concave down. Concave up from 0 to 8. Concave down from 8 to 18. Ding, 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 ding. Okay, here's part C. It says, hey, where's the inflection point? I don't know. It's probably 8, 350? Ding, 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 ding. All right, yeah, okay, next question. I have this one next problem here. It literally takes front and back the whole thing. But then I'm done. So this is the last question I have. But it is the biggest problem I've ever seen in this class. And I don't know. I feel like, I want to skip it. I know you would want to, but, you're paying me, so here we go. You're paying me to do math homework with you, not for you, it's with you. Right? Isn't that how it works? So let's do this thing and be done with it forever and ever. And so you might be wondering, are these skills important later on? Minimally, yes. So yes, just not every day. All the stuff again. So here we go. I got this thing. I got an interval and no clue what this graph looks like. Again, if I had a graphing calculator, I'd just plug this thing in and start looking around. I'm sure I can guess better than anything. But we don't have that available to us because that's not part of this class, unfortunately. So let's do some derivative action. The 2 comes down to the front, makes a 12, leave the inside alone. Derivative of cosine is a negative sign. That's the chain rule going on, okay? This is technically 1 power now. Same thing with this, well, not the same thing with the sine, but sine will go to just plain old cosine, like that. And I want to set this whole thing equal to 0. Well, the funny thing is that they both have a 12 cosine. So guess what? I'm going to pull out a 12 cosine, leaving behind a negative sine x and then a minus 1. Is that what I did? Kinda, yeah, I did. In fact, I moved the negative sign out to the front as well. So I got my sine x plus 1. And then both of these equal 0. Okay. So cosine of x is equal to 0. Ignore that 12. You don't need that thing. And so... wow, that was so fast. Okay, so cosine equals 0. That's my x value equal to 0. And that's going to happen at x equals pi over 2 and 3 pi over 2. And so on and so forth. That's good enough for now. In fact, you can tell that it says, look, this is the only interval we're looking at. This is the interval numbers that we like, so we're done there. This one over here says that sine is equal to negative 1. And what's going on here is that it's straight down on my unit circle, 3 pi over 2. Now, they have some overlap, and that is okay. We'll just say that it's both of them. We'll keep going. All right. Second derivative. So... what do we do with the second derivative? Should I take it with this guy or something else? I don't really know. I mean, the next, like the half page is full of derivative here. So I think what I want to do is I'm going to do this right here. I'm going to take it from right here and start doing a derivative. So the negative 12 can come to the front, and then I got product rule. This is F, and this big thing here is G. And so I'm going to take the derivative first, which is going to be a negative sine x, and then I leave the second one alone. And then I leave the first one alone. And then I take the derivative of the second one. Sine goes to cosine, and the 1 goes away entirely. Okay. F prime G, F, G prime. And the 12 is multiplied by every single term. And so what we actually end up getting here in just a second, let me just, hold on, do this thing first. I got negative sine squared minus the sine, and then over here we got cosine squared. Okay. I am noticing some particularities. Yep, that's right. I did something completely different here in my notes. Oh, wow. I did something very different in my notes. That's okay, that's okay, that's okay. So I want to set this thing equal to 0 to find all the inflection points, right? These are critical points. These are going to be inflection points. And the only way that I see to do this properly is to either try to convert this over to a single something, which I don't think that's going to work here. I know you're seeing a trig identity in there. I don't think that's what we're looking for. I want to focus on this stuff here. Now, here's another thing. Because this whole thing is equal to 0, I can actually just get rid of this negative 12 entirely, okay? Right now. In fact, you can change all your signs to be negatives and stuff as well, which I will do here in just a second. So I've got sine squared, I got a sine, and I'm going to convert this over to a 1 minus sine squared, okay? Now, every one of these, whenever I distribute my plus sign, and I combine these guys together, they're all negatives. So that's a 2 sine squared of x minus sine x, and then a plus 1 equals 0. Just pull a negative sign out, and then, I don't know, move it to the other side. It's going to go away. I'm trying to make this as clean as possible for whenever I do quadratic formula. Okay, hold on. Whenever I do something with it. So I want to factor this guy. And the problem is not going to need quadratic formula, but you definitely need to be able to factor this thing like this. Notice that this is some kind of like 2y squared plus y minus 1. This is not far-fetched, okay? I know we've done this before. Back from algebra, in pre-cal, all kind of places. So I'm choosing a 1 right here and a 2 because there's a prime number, so you just put one of them somewhere. There's a 1, I guess. And then 1 times 1 is a 1. And so it's negative. There's positive right here. So if that's a positive 1, I'm going to put a plus sign here and a minus here. The reason why is because when I start foiling, I get, well, exactly what I want. You can go and check it. It should be fine. There you go. So I now have 2 sine x minus 1 equal to 0. And here I've got sine x is equal to negative 1. Again. So I've got sine x is equal to 1/2. And then my sine x is equal to negative 1. Okay. So where is this happening here? What is my y value equal to 1/2? It's right here. Positive half right here and here at pi over 6 and 5 pi over 6. What about this guy? Well, it's straight down at 3 pi over 2. And so those are my answers that I have for this one. And again, all of these are inflection points. Now, again, how do I have this one twice? Isn't that weird? Surely that's weird. So I have an inflection point at the same time that I have a minimum or a maximum or something like that. Very weird. Okay. So what do we do now? How do I understand all this stuff? Let's start figuring it out, I guess. I'm going to do a number line. Let's start with 0 and go to 2 pi. And right now, I've got critical values at my pi over 2 and my 3 pi over 2. So these are critical values right here. Okay, so that's something. And then I have these inflection points right here at pi over 6, 5 pi over 6. This is going to be pi, so it's a little bit before that. 5 pi over 6. And then again at this 3 pi over 2 business. Kind of weird there again. I need to split all this up and see where I'm increasing and decreasing and plugging things in and all this kind of stuff. And okay. Oh my goodness. So let's just talk about it for a minute here. I need to test some numbers out, and I'm going to test out a number here. Let's say I'm going to test, this is my test numbers. I'm going to test out pi over 4. I also want to test out pi, and I want to test out 7 pi over 4, which is way over here. I'm going to test these. And how do I test them? Well, I'm going to plug them into my f prime, okay? So I'm going to plug them in to my first derivative. And I just want to see what's going on here with my first derivative. So that's way back over here. This guy or this guy, whichever one you choose. And I want to know if it's increasing or decreasing or whatever. So I plug this guy in, and I got a negative number. And so therefore, he's decreasing. I'm going to just put a DE for decreasing. Okay. I plug in a pi, and I got positive. And so this is telling me he's increasing. And then I'm plugging in the 7 pi over 4, and guess what? I got negative. That means he's decreasing. So he's decreasing, then he's increasing, and then he's decreasing. Okay? So you can kind of do this here like that. That's kind of what I'm thinking. So far, at least. So far. And so if they're asking for intervals of increasing, decreasing, which, well, guess what they are, it's going to be a pi over 2 and a 3 pi over 2. And then for decreasing, it'll be negative infinity over to the pi over 2, comma, 3 pi over 2 to 2 pi. Awesome. Okay. All right, next one. So, I mean, we're going to need to know concavities and all kind of stuff. So, I need to figure out what's going on concave-wise. And so what I want to do is I'm going to use my critical points here and here. And I want... Actually, I can't use that one. I want to use pi. I don't think I have a pi in there, but anyways, I want to know what's going on here at pi over 2 in particular, okay? So apparently right here there's an inflection point right here and right here. So is this concave down or is this concave up? I don't know. And so what I'm going to do is plug that in right now, f double prime at pi over 2, and I want to see, is this, you know, some kind of inflection point or something like that? Well, when I plug this in, I got a negative 12. Hang on to that number. And negative means that it's concave down. Concave down at pi over 2. Okay, hold on. This is fine. And so what does this mean here? I mean, my graph is just not going to be very good for you here pretty soon. It's concave down. Oh, I see. I think I mixed up my answers. That's okay. It's not really okay. Can I plug that in for reals? Oh. Pause. Gosh, man. This problem is just crazy. Back up. I messed up. I didn't see something. I'm sorry. I messed up. I plugged in the pi over 2, and I got positive 24. Whew, this makes so much more sense. Positive. Concave up. Look, isn't this concave up? See, I was getting worried. I got the wrong value, so forgive me. I'm sorry. Just so many flying pieces going around right here. And if you're confused, so am I, obviously. This also then tells me, because of all this stuff, concave up and whatnot, that this is a minimum. And does that make sense with what I have on my graph so far? Yes. Great. All right, so when I do my 3 pi over 2, I get a 0, which I already knew that was going to be something weird. I have an inflection point at the same time. I don't really know. There's nothing really to be said there. I want it to be a maximum, but it's not quite saying that. And I don't know. We're just going to leave it alone for right now, okay? So here we go. Let me go ahead and tell you how to make all the rest of this work. I hope. So this is just a strange thing, but we're just going to have to roll with it, okay? we've got my f at pi over 2. This is my original. I'm going to plug in my original. And this is where I get that negative 12. This is my minimum value, okay? And apparently, it is a maximum when I plug in the 3 pi over 2 because I get a positive 12, and that's my maximum. But I still got a lot of question marks because it is way strange that this is happening. Okay. But does it make sense with this graph here? Yes. And if I just didn't even think about the inflection points for just a little bit, I mean, like, kind of just like ignore that, wouldn't it make sense that this is all concave up and everything else is fine? Sure. So, positive 12, put it in. All right. Last bit, we're so close. Gosh, man, I'm just so confused about this huge problem, and it's just taking forever, and I'm very sorry for any confusion. Just go back and rewind a bit, I guess. I don't really know. This is not my most stellar work. It'll get better. Maybe. So, inflection points. I'm going to go and plug in these to the original to get my y values. I already had my x values back from whenever I actually had done stuff here. And apparently these are my 2 inflection points at all, and that's what we're going to have. I just want to pause and talk about the inflection points. I finally figured out what they are trying to get at, okay? And what I feel is that I need to recap on all this because it's just too much, man. It's just too much. And then finally, so concave right here, let's go back. Concave up, concave down, and I think it's going to be a concave up again right at the very end, okay? So concave up, concave down, concave up at the very end. But between all these points, here we go. Concave up. All of this answer, here we go. I've got pi over 6 to 5 pi over 6, and, well, that's actually all there is. So I was mistaken. This is all the answer is. Concave down, though, is a lot more. 0 to pi over 6. 5 pi over 6 to 3 pi over 2. And then 3 pi over 2 to 2 pi. Wow. There is so much problems with this problem. Okay. I would recommend graphing this thing to be able to see what's going on here. And I can't show you that right here, right now. Don't I have a graphing calculator, I don't know, nearby? So, yep, my batteries are actually out. Isn't that wonderful? Right there in the middle of the recording. So, well, you know, we do what we can. So, let's just pause. Hold on. I sure hope that paused. So, I have a graphing calculator with batteries now. And I am going to graph this. I cannot show you because I don't have internet. But it's okay. So what I want to do is I want to graph this thing. And I'm going to show you what it looks like because I'm curious now. So that we can analyze together what is going on with this problem. Okay. Of course, the TI has got to take another 10 minutes to figure itself out there. Okay. So, you know, sometimes we got crazy problems, and I'm doing the best I can to work through with this here. Apparently Y scale is not good enough. And I'm going to change my X scale here to be the 0 to 2 pi. So here we go. Oh yes, I got something going here. Here we go. We've got it going down, coming back up, capping out. I totally understand now. And then it starts to do this. There is your graph. This is 2 pi. This is where we end. Now, wouldn't it have been nice to have that in the very beginning? Because look, let's go back through some of my answers. I'm decreasing. I'm increasing. I'm decreasing. This number here is at pi over 2. And this number here is at 3 pi over 2. Okay, so we got that far. That was excellent. Now, there is an inflection point right here at pi over 6. There's an inflection point right here at 5 pi over 6. These are my answers if you remember. Look, look. Wow, and it's almost at the same y value, so let me try to make that look a little bit better. There we go. Yay! Okay, those are my inflection points. But then, ooh, they were saying that that was an inflection point too? But no way. No way that's an inflection point. Do you know why? Because it doesn't look like one. But yet, I still have to do this concave down, break it up kind of stuff. And that is super annoying. What's going on is that it's actually horizontal for just a whole split second right here. It's just horizontal for just a split second. And therefore, my concavity, it doesn't change, but at this split second of horizontalness, it doesn't quite have the concavity that it should have. I think this is a very confusing problem. But here's the point. Wouldn't you have rather me do this with you than me to say, you got it? So it's confusing to me. It should be confusing to you. And on the homework, if you're ever confused, guess what? Graph it. It's at least something that you can do on the homework. I know that you can't have it on the exam. I get that. But your exam, I would hope, is not this difficult. And if it is, you come talk to me. Okay. We're done. We're done with this section. That was a pretty darn long section. And I know that sometimes I'm like losing my cool, and that's just part of math, I suppose. It's a daily struggle. Thank you very much, and have a better day.